Imagine waking up in the morning. You stretch, yawn, and glance out your window. The sky looks wrong. There's no familiar golden glow. No warm sunlight spilling across your street. Instead, there's an unnatural darkness, an eerie shadow engulfing the horizon. What if that darkness wasn't just a thick cloud or a power outage? What if it was the beginning of the end? A black hole, invisible and merciless, drifting silently toward our sun. And right now, it's beginning to swallow the very star that gives us life. Can you feel it? The cold dread creeping up your spine as the reality sinks in. The sun, our fiery, radiant life source, gone. What happens next? How does the world respond when the source of all light, warmth, and energy disappears in an instant? Would you fight to survive? Would you look for hope? Or would you simply stare into the abyss? Before we face this cosmic nightmare, let's take a moment to understand the star at the center of it all, our sun. The sun is no ordinary ball of fire. It's a colossal, violent furnace made mostly of hydrogen and helium gas, held together by gravity. Its diameter? Around 1.39 million kilometers. That's more than 100 times wider than Earth. Inside the sun's core, where temperatures soar to a staggering 15 million degrees Celsius, hydrogen atoms smash together in a process called nuclear fusion. This fusion converts hydrogen into helium, and in doing so, releases unimaginable energy in the form of light and heat. But here's the catch. The photons born in the core don't reach us instantly. It takes thousands, sometimes hundreds of thousands of years, for them to slowly work their way out through the dense radiative zone, bouncing, scattering, before escaping through the convective zone, and finally radiating out into space. Only then do these rays begin their 8-minute journey to Earth, traveling 150 million kilometers at the speed of light. Think about that. Every ray of sunshine warming your skin is the result of a cosmic journey spanning millennia. Can you imagine a star so vast and powerful, yet so delicate, that a single cosmic event could end its life instantly? What would you do if you learned tomorrow that our sun, this gigantic furnace of life, was about to be swallowed whole? Would you savor the light while it lasts, or prepare for the unimaginable darkness ahead? Now, meet the antagonist, the black hole. Black holes are cosmic monsters, born when massive stars die and collapse under their own gravity. Imagine compressing a mass greater than our sun into a tiny sphere, so dense and powerful that its gravity warps space-time itself. The key boundary here is the event horizon, the point of no return. Cross this invisible line, and escape is impossible. Not even light can break free. Picture a cosmic whirlpool. Anything caught in its pull gets stretched, torn apart, and swallowed whole. If you had the chance, would you dare to observe a black hole swallowing a star? Or would the terror of witnessing such destruction drive you away? What do you think happens inside a black hole, where all known physics breaks down? In some rare cosmic dances, black holes and stars come dangerously close. When a black hole edges near a star, it begins to tug on it with tidal forces, gravitational forces so strong they can distort and rip the star apart. This ripping is called spaghettification. The star stretches into a long, thin stream of plasma before ultimately being devoured. The star's gas doesn't just vanish quietly. Instead, it forms an accretion disk around the black hole, a furious ring of swirling matter heated to millions of degrees, glowing brightly in X-rays and gamma rays. Astronomers have observed such events happening in distant galaxies. But what if this happened to our sun? Imagine that slow, terrifying process unfolding above your head. The black hole drifts silently into our solar neighborhood, invisible, but its gravity announcing itself with an invisible, crushing force. At first, the sun feels a subtle tug, a whisper in the vast cosmic ocean. But within seconds, that tug becomes a violent pull. The side of the sun, facing the black hole, experiences stronger gravity than the far side. This difference, called a tidal force, begins to stretch the sun into an elongated shape. Imagine squeezing a water balloon from one side. The fluid inside strains and stretches. Pulled taut, the sun becomes a glowing, fiery spindle. Picture the sun stretching, twisting like cosmic taffy. Can you imagine the immense power it takes to distort a star 1.39 million kilometers wide? What emotions stir inside you, imagining our life-giving sun turning into a dangerous sliver of plasma? Would you try to capture these last moments on camera, or simply stare in disbelief? The sun's outer layers start to peel away. Streams of superheated plasma escape, spiraling inwards towards the black hole's event horizon. This forms an accretion disk, a blazing, spinning ring of star matter, emitting fierce X-rays and gamma rays. For distant observers, this disk becomes brighter than any other object in the sky, a deadly cosmic lighthouse. Inside the sun, fusion reactions grow chaotic. Pressure drops in some areas, surges in others. The core begins to collapse, pulled inexorably toward the dark maw of the black hole. And at this stage, the physics is extraordinary. As matter spirals inward, it heats to millions of degrees due to friction and gravitational forces. The energy emitted is so intense, it can outshine entire galaxies in specific wavelengths. With the sun gone, gravity's anchor is lost. Planets, no longer held in orbit, shoot off in straight lines, tangent to their orbits. Earth, once revolving at 30 kilometers per second, hurtles into cold, dark space. No sunlight means no photosynthesis. Plants die. Oxygen levels drop. Temperatures plummet. Within days, Earth's surface freezes. Humanity faces a nightmare unlike any before. If Earth was hurtled into darkness and cold, would you try to survive underground, powered by artificial heat? Or would you attempt to build spacecraft to escape the dying solar system? What's your survival strategy when the ultimate source of life disappears? The instant the sun is swallowed whole, its gravitational grip on the planets vanishes. Earth, Mars, Venus, all lose their orbits. Imagine being strapped to a roller coaster that suddenly lets go of its tracks. You shoot off tangentially into the void. Earth hurtles in a straight line through the black emptiness of space at 30 kilometers per second. But now, no light, no warmth, just infinite darkness. Close your eyes. Imagine that moment. The sun gone. The sky doesn't glow. The familiar warmth evaporates. Temperatures plunge rapidly. Within a week, the average surface temperature plummets below -70 degrees Celsius or -94 degrees Fahrenheit. Most humans and animals perish. Imagine standing in the ruins of a frozen Earth. The sun swallowed by a black hole. Our once brilliant star, now a dark memory. The universe feels vast, cold, and indifferent. Yet here we are, the last sparks of life clinging to hope. Think for a moment. If the sun can be destroyed in a cosmic instant, what does that say about our place in the universe? Does it make life more precious or more fragile? Would you find meaning in the struggle to survive or in the knowledge of our inevitable end? I want to hear from you. What do you think about this cosmic vulnerability? Would you build a bunker underground, try to escape Earth, or find peace with the inevitable? Comment below. Your thoughts might inspire someone else. All right, though the sun's hypothetical fate is terrifying, remember, Our star has burned steadily for 4.6 billion years. It will shine for another 5 billion, giving life, warmth, and energy. This vast stretch of time is a gift and a chance to explore, to understand, and to marvel at the incredible cosmos we inhabit. If you enjoyed this deep dive into the sun's mysteries and its terrifying hypothetical destruction, please like, subscribe, and share this video so more curious minds can join this cosmic journey. Hit the bell icon to never miss an update and share your survival strategies in the comments.